10 says Mildred the cow is tied with a rope to the side of a square shed with side length 10 meters. So the rope is attached to the shed at a point 2 meters from one corner of the shed. The rope is 14 meters long. The area of grass growing around the shed that Mildred can reach is given by n pi squared meters, where n is a positive integer. So this problem asks us to find n. So let's first draw the shed. It's just a 10 by 10 square. So each of these side lengths are equal to 10. So let's assume that Mildred is tied here, and these two lengths are both 8. 2 and 8. Let's see where Mildred can reach. We know that the rope is 14 meters long. So let's say this is 14, and this is Mildred. So how are we going to draw this, first of all? Circle. So is it a full circle? No, it's not a full circle. Let's consider two different... Okay, so we want to draw half the circle. Yeah, we can do that. So it's going to be something like this, where this is 6 and this is 10. First, we can draw this semicircle because we know that Mildred can definitely reach any point within this semicircle. So okay, so you said that we want the other corner to bend. Yeah, that's perfect. So if we have Mildred here, once she gets to this point and she wants to go further, she's blocked by a certain amount because the rope is basically stuck on this corner of the shed. So what happens is that at this point, Mildred can only go in this quarter circle because anything past this point, she'll basically have a rope of length 6 that's attached to the corner. So this is like as far as Mildred can go. Okay, and then on the opposite edge, and this is a good observation, that after Mildred wraps completely around, there's still going to be 2 left. Yeah, that's correct. And then another quarter circle. Yeah. So then after Mildred wraps around the 2 sides of the shed, she can still go to the back of the shed, basically. And then she can go anywhere within this quarter circle of 2 meters. So now we have 1, 2, 3 semicircles, 3 quarter circles, and 1 semicircle. And we want to find the area that's contained by this region, because we want the area of grass that Mildred can reach. And we know that she can reach every point inside this region, but she can't reach any point outside of this region. So now we just have to find the area of this region. So first of all, what's the area of this semicircle? The big one. This semicircle. 14 pi squared? 14 squared pi. Halves, yeah. So because the radius is 14, it's going to be half of 14 squared pi, which is going to be 98 pi. How about this quarter circle? The largest quarter circle with a radius of 12. Has a radius of 12. Because it's not 25 pi. The radius is 12 because she reaches this. So what would the area be? So the area of this is going to be 36. Now, yeah, exactly. 3 times 12, 36. We have 2 more to go. First of all is this one right here, another quarter circle. This one has a radius of 6. So what's the area of this one? What's the area of this semicircle, quarter circle, sorry, with radius 6? 9 pi. Yeah. And now we have one more, which is this small one, which has radius 2. It's pi. So if we add them all up, what do we get? we get exactly 144 pi. And that's the answer. So this question it's really good because it doesn't just make you apply one formula. You have to first find the region. Yeah, we have to first find the region and then we have to calculate the area. And at each one, we can't just say this is just a quarter circle and we're done. We have to see if and if where it wraps around to create another region. And that means the problem is more than just calculating the area of a bunch of quarter circles. It's also about like finding what what regions this cow can go and finding the area of those.